I just want to quickly go through complex numbers with most of the things you need to know, how we convert between the different ones, and then do a couple of exam questions. So we have three types of forms for complex number. Plot it on the Euler diagram as we did before, and it's either in general form, x plus iy, that's for this coordinate right here. But if you convert it, so if you work out using Pythagoras' theorem the modulus, and you work out the angle, so r is x squared plus y squared, square rooted, and theta is tan inverse. That will allow you to write this in Euler form, as Mr. Ray showed you before, so r e to the I theta, or in polar form, which is r cos theta plus I sine theta, and sometimes we just write it as r cis theta. So there's three different forms. You have general, Euler / exponential, and polar form. Let's take an example. So let's take 2 plus 2i. Now, if I want to convert this into Euler and polar, I need to find r and I need to find theta. On an Argand diagram is in the first quadrant, where that's going to be 2 and that's going to be 2 as well. So to find the length, I do 2 squared plus 2 squared square rooted, which is root 8 or 2 root 2. So r is root 8. Theta is tan inverse of this. So I do tan inverse of 2 over 2, which is pi by 4. Therefore, in Euler form, it is root 8 e to the I pi by 4. In polar form, it will be root 8. We write cis theta, or so you can write cis pi by 4. Or you can do root 8, actually I won't write it in that's the next question, root 8 cos pi by 4 plus I sine pi by 4. Either's absolutely fine. When I'm raising it to a power, let's say I'm doing z cubed. The easiest way to do this always is to do it with Euler form. So you want to take this one here. I want to raise this to the power. So I do root 8 e to the I pi by 4, and I cube it. So I do root 8 cubed, which when I put that in my calculator is 16 root 2. And then if you think about powers, I'm just multiplying the powers together. So I get e to the I 3 pi by 4. Same thing to the power 4. If you do it, you will get, check it's right, 64 e to the I pi. Now, if I want to sketch these on an Argand diagram, okay, the key thing to note is that each one is a rotation, because the argument, the pi by 4, is getting bigger. So if I have z being here, that'll be z. Z squared is twice the modulus. In fact, I'm going to make z a little bit smaller. It's there. Z squared will be here. Z cubed will be here, and Z4 will be kind of out here, where the angle is increasing. So you've got pi by 4, you double it, so you get pi, you triple it, so you get 3 pi by 4, and then you do it to the power of 4, so you get pi. Very last thing. If Z is 2 plus 2i, I want to state the modulus of W if Z over W lies completely on a circle. That means that the modulus of Z over W is 1. Therefore, mod Z equals mod W. Mod Z, we just said, is root 8. Therefore, mod W will also be root 8. That would be because then when you're raising it to powers, if the modulus is 1, 1 squared is still 1. 1 cubed is still 1. So anytime you're plotting it on a circle, it just stays, plotting an Argand, I'm sorry, it stays on a circle. Thanks, guys.